Okay, class, we're ready to begin our Zoom lecture. I'm thinking that the Blackboard quiz is no longer available. It should have ended now. Okay. I'm looking at the grades. So it looks like I don't even have to review much from the actual quiz. But I will if you want me to. Let me pull up something real quickly. Okay, can everyone see the screen? Can everyone see the screen? Just say yes or no.
Yes.
Okay, great. All right, let me go ahead real quickly and review just this one problem because it appears that the understanding for the other problems is clear. So that's great. But I do want to show you something here. You want to use a picture. And of course, this picture then will help you to decide the signs for your problems. And if you watch me very quickly, you can see how this problem on the exam on Monday should not take you much time. So 21 kilometers north of east. So this is north of east. So here, this is 21 kilometers. And of course, this angle is 45 degrees. So immediately upon seeing a 45-degree angle, the first thing you know is that your X and Y components are equal. Also, they are positive. So you want to move quickly through this. Now you know that when you have a right triangle that's equal, if you recall from high school, if these are equal, okay, this is your side, and this is your side, and this is your hypotenuse, that the hypotenuse is always equal to the square root of 2 times the side. And therefore, the side is always equal to the hypotenuse divide the square root of 2. That will save you some time in the exam. So when you take 21, see, this problem won't even require you to do that entire chart, because once you see how this problem is set up, then you can just go quickly and say 21 divided by square root of 2. And when you do that, you should get 14.8. And they're both are positive. 14.8. I think I saw that in some of your answers. Now, the next vector is vector B. It is south of east. So you see north of east, south of east. So of course, south of east means that I am in this quadrant where X is still positive, but Y now is negative. Now again, you should recognize this angle, 36.9. You will only see that angle, class, in a 3, 4, 5 right triangle, which means that if this is 15, then this these are my angles. This is my smaller angle, and therefore this must represent my smaller side. My smaller side is a factor of 3. So I say, what times 15, what times 5 gave me 15? And of course, that's 3. Therefore, immediately, I know that this side is 9 and this side is 12. Because remember, the 3, 4, 5 triangle has sides that are multiples of 3, 4, 5. So once I recognize that, then I can quickly put my answers, 12 and -9. Then for vector C, it is west of south. This is important. Watch very carefully. You move to the west from south, which means that this is my angle. So if this angle is 30 degrees, then if I complete this triangle, the opposite side, as you can see here, is parallel to the x-axis. So if I don't want to do that, I complete the parallelogram. Now this is 60 degrees. So now I can say cosine of 60. And of course, both of these numbers are now negative. So I take the cosine of 60. That becomes my what? My x-axis. The sine of 60 becomes the what? Component of my y-axis. Now class, I'm taking the time to show you this because I want you to see all these tricks. I want you to know that these exist so that in the exam, not just this exam, but you will see the use of these triangles, the 3, 4, 5, the 45, 45, 90, and the 30, 60, 90. You will see these throughout your career as engineers and physicists, because these are so common and they're often used. And also it can help you if you have to guess a problem where the angle is not, say, 45. Say the angle is 44 or 46. That would mean then that these legs are still close as far as their magnitude. Or say you have a 31, 59. Still, they are so close to 30 and 60, you can recognize what these are. And I hope you recognize in this problem, the 12.5, which is my y component here, which again, let me take that off, hold on. Okay, if you notice here that the short side in this case is what? Half of the hypotenuse. Hypotenuse was 25, so the short side is always 1/2 of that. And the long side is always 0.866 times the hypotenuse. So I wanted to point that out because in the exam, I want you to quickly look for clues. You see, there are actually problems that you can solve somewhat mentally if you know what the common knowledge is. And I want these students, I want you students to have the same common knowledge that the ones who are, say, at Auburn University or Georgia Tech or MIT. This course that you're taking this summer, I want you to feel just as prepared as if you were in some school that's highly taught it, like some Ivy League school. And that's why I'm taking the time to teach you these tricks. So are any questions about that problem? Now, to get the answer, you must look at the question. It says use the component method. That's what this is, of vector addition to find the resultant of the following 3. So the resultant now, the answer you want to give here is what is the magnitude of the resultant vector? That means then that I must sum these up and get the x and y component of my resultant vector. And when you do that, you will find that vector R has 2 components. It has an x component. We say that is 5.1. and it has a y component, negative 6.7, when you sum that up. So what does that mean then? That means you have a new vector, which is your resultant vector. And that resultant vector, I'm going to go to this corner right here. Your resultant vector has an x component that's positive and a y component that's negative, which means I'm going to go over here and come down here, and that's where that vector is. So that vector now, class, has magnitude that, of course, we have to use Pythagorean theorem to find the magnitude. So I have 5.1 squared plus 6.7 squared, and that will give me, I think it was 8.4. So 8.4 kilometers. That's the resultant magnitude. Now, a vector has both magnitude and direction. So now I want to know, what is this angle? Now, if I measure this angle, I would take, of course, inverse tangent of opposite over adjacent. And if I do that, I will get 52.7 degrees. But if I just leave it like that, class, it would appear that that resultant vector is in the first quadrant, because I didn't tell you that it's 52.7 degrees, what? South of east. So I say southeast. Now that tells me the magnitude and the direction. So that is the final answer that I'm looking for. Now, in the exam where you must show your work in a problem like this, the advantage is you can get partial credit. So I'm looking to see, did you do the x component right? Did you know that this angle was in the what we call unconventional form, so that you would have to at least say sine to get the x component and cosine to get the y component? If you were able to do that, I'm looking for that. I'm looking to see that you complete the problem to get full credit. But if you get partial credit, if I see any of the work that's needed to find that answer. So please, please, please pay close attention, because problems like this in the exam will have multiple parts, and you want to get all your points. Any questions? I know it looks a little junky there. I hate that, but that's what it is.
So
okay.
On problems like these, on the component method, you don't want us to round our answers as we go through?
Okay, very good question. Thank you for that question. So what happens is this, class. We discuss significant digits, and I want to go over that again. You notice here that the smallest number of sig figs in this given is 2. So my final answer needs to have 2 significant digits. In fact, for my angle here, I should say 53 degrees, because this is 3 sig figs and it's more precise. Now, normally you would go with the smallest number of significant digits is given in the problem. So if I had put 21.0 even here, this answer, if all these had 3 sig figs in the given here, then this answer also would need to have 3 sig figs. But because the smallest one here has 2, therefore the answer can only have 2. So in this chapter, the author wants me to stress the use of significant digits, and that's why the answer should be in 2. Now, for your answer to be correct, and that's why we have only one correct answer, is because when you're doing the intermediate work, you should go one digit beyond what is given. So your intermediate answers, like in this case, 21.7, you should put that in your intermediate answer rather than 22. Right here, you should put 12.5 rather than 13. Because if you began to increase these numbers, if you begin to adjust these numbers too much by rounding, your answer is going to be incorrect. So all of us must have the same pattern that we follow. And that pattern is this: go one beyond what is required in your answer. So in this answer, because two will be required, the intermediate answers should at least have three digits given. Does that answer your question?
Yes, ma'am. So on this quiz, if we round it because we didn't know, are you taking off for that?
No, because see, as I'm teaching this class, I'm also finding out what I need to stress. So in this quiz, I will not be reducing points for that. But of course, now that I have explained it to you, and I hope you understand it, now going forward, I can use that rule because now I've found a way to explain to you what is meant by significant digits. Because when you're working in a scientific lab, there is one answer that everyone that's researching and doing it correctly should get. One unique answer. Some shouldn't be getting 51.3, others getting 52.5, others getting 54.7. That shouldn't happen, because if we all follow the rules, we will report one precise, unique answer. And that's so critical in the scientific field. Can you imagine scientists trying to send man to the moon and everybody's giving different data? We wouldn't be able to do it. We couldn't even make a cell phone or build a building or even do any production unless we were able to come to a unified, specific, unique answer. Okay, let's look now at the other problems very quickly. Okay, so here's the answer here. Now, again, one of the skill sets that you are to gain from this class is the ability to turn words into pictures. And I stressed that in my notes to you. So a pole is held vertically by attaching wires at a height of 15 meters above the ground. So that means that this pole then has to be 15 meters above the ground. This is my pole. The other end of each wire is anchored to the ground at a distance of 12 meters from the base. So that means I have, and it's anchored like this. And this is 12 meters, and this is 15 meters. And of course, it's on both sides like this. So this is my anchor at the base. This is my pole. And of course, it says the pole makes a right angle with the ground. That tells me what? I use Pythagorean theorem to find what? The length of each wire. The wire is so many meters. Okay, any questions? Any questions? Let me go to chat. I think I see someone. Okay, all right, I see that. Any questions from anyone? Okay. Okay, let me go to the next problem. Okay, same thing here as far as needing to draw a picture. So on number 3, the picture simply says a certain mountain road is inclined above with respect to the horizon. So of course the horizon is along the what? The x-axis. This is my horizon along the x-axis. So the road is inclined, which means it has an angle, and this is given as 3.5 degrees. What's the change in the altitude of the car? So the car then, of course, is traveling along the road. And as you can see, it's getting higher and higher and higher And that's what is meant by changing altitude. So when it says what's the change in altitude from where it starts to where it ends, I simply want to know what is my y component. What is the change? Traveling along the road, and it travels along the road, which is 3.5 kilometers. It travels along this road. So now, once you analyze the problem and identify the components, then of course you can say, okay, this is my opposite side. Sine of theta is opposite over hypotenuse. So y then is going to be sine of 3.5 times the hypotenuse. Any questions? Okay. 4 and 5, I've already gone over these two problems because these two problems were in the assignment that we had earlier this week. The only thing I want to point out now is that in problem number 4 and one like number 4, what if I told you that how long does it take for the rock to reach a depth? And what if I had said, for example, something easy, 300. What if I had said, for example, 320 feet? Can someone tell me how you would handle that problem a little differently? You can come off remote mute and tell me, how would you handle this problem differently? Okay, so I'm thinking that you solved the problem by saying h is 1/2 gt squared, and you said t squared was 2h over g. So now I want to know, how would you solve this problem differently if I gave you a problem like this? Okay, you can speak. Does someone have a clue?
I would convert the feet into meters.
That's one way. That's a little longer. Okay, that's an extra step. You see, I'm giving you a clue. That's an extra step. Does anyone else have a suggestion? That's a good, that would be absolutely correct to do. Okay, but it's someone else?
You could change the G to 32.
Okay, you can change, and when you say change,
You use a different unit.
You can use the different units, exactly. So G is 9.8 meters per second square, but on your equation quiz, which you'll be using during the exam, if you haven't learned it, it's also 32 feet per second squared. So you see, there's no need to go through the extra step of converting H to meters when you already have a unit for G that is in the units of feet per second squared. So make sure you understand that all these little tips is what I want you to know. I know that there are students who've taken the ACT, and because the professor did not give them the heads up on things to look for, they were stuck and they spent too much time solving what they should have just known. So I want you to know certain things. You don't have to reinvent the wheel on these exams. Now, the reason why I wanted to have the quiz today, I need to be able to time you to see about how many problems you can solve in an hour and a half. Now, on the exam coming up on Monday, a portion of the exam will be on the screen. A portion of the exam will be in Blackboard. And once you finish the exam and submit it in Blackboard, we will be able to go over it, because I'll begin a new chapter on Tuesday. So the exam will be just a little longer than this. And I hope to have it done like we're doing now by 2:40. So you need to be in class on time, 1:30. By 2:35, you should be done. The exam will end. The multiple choice part that you will see will end. And that'll give us a few minutes to go over it and answer any questions, so you'll know how you're performing on that first exam. Okay. Okay. I need to know then what we will be doing. We only have 5 more minutes. Okay. Any questions about anything? Now,
You said the exam was going to be over chapters 1 and 2?
yes,
Okay.
the exam will be about an hour and 5 minutes, which means you need to be on time for the part that's on the screen. You started at 1:30, and then at 1:45, I will open up the other part. You will have all those questions. I see you were able to do 4 in less than 30 minutes. So if I give you 10 problems, you should be able to finish those within the next 35 minutes. And let me see. Oh, so you can have your equation quiz in front of you. You can have your notes in front of you. I would have my calculator, make sure that my batteries are good, pencil, and I'm not going to try to be doing any lockdown and all that. I'll just do how I did today. But the problems, of course, will be a little different because I don't want to keep giving you the exact same problems. Of course, some of them will be the same, but they'll be a little different to see if you actually have learned the material as opposed to just memorizing the steps. Learning is different from memorizing. But of course, memorization adds to learning. So if I were you, I would learn my equations, I would learn my constants, I would learn my SI prefixes, at least the common ones like centimeter and millimeter and kilometer. I would learn those. I would practice manipulating my exponents, making sure I know how to multiply and divide exponents, both positive and negative. All those things you want to make sure that you're really sharp on them. So you have Friday, Saturday, Sunday, and then our exam will be Monday at 1:30. Any questions? Okay. All right. Well, but I have a couple of more minutes. To me, I feel a little bit of a disadvantage in this course, meaning that, for example, I would like to have seen your pictures on this problem with the ladder, because that would help me to see how you're thinking. I would like to have seen your picture when you had the card going up the inclined plane. So if you want to sometimes, if we can find a way for you to send me that, maybe you can send it to me in text, because I have a picture of what you're doing. And that way, if you have any difficulty, if I see your pictures, if I see your work, then I can go over that with you. So I said that to say this: if you're working on a problem and you have a question for me, before you call me or contact me, take a picture of it and send it via text. And that way we can discuss the problems and I can make sure that I'm understanding what you're doing. Now, I have the YouTube videos, and I'm going to give you the link to those. I think I sent one link already. So hopefully after today's class or by tomorrow, I will make sure you have all the ones that have been recorded thus far. I think we may have Tuesday, Wednesday, and today. And I'm going to try to make sure I have that done each day. I have some good assistants. Someone is helping me, and I value their assistance. And I'm going to put that up for you. So hopefully today I'll go over that. I'll send that to you, today's lecture, and you will have that to review. Any questions? Okay, well, as usual, as you sign out before you leave for today, please type your name in chat. Have a blessed weekend. Probably need to go to church somewhere this Sunday. Have a blessed weekend. Enjoy yourselves. Take care. Try to stay out of the rioting and the marching, and well, I won't say marching because I think they said peaceful assemblies are okay, but as you can see, a lot of these peaceful assemblies aren't showing up so peaceably where I can see. All right, type your name now and you are dismissed.
Dr. Edwards,
Yes, sir.
what was the answer for 4? Because that's the one I missed. I don't.
Number 4, I have 17 meters per second. That's actually the exact same problem from the earlier assignment. I didn't change that problem.
Yeah, in my notes, I was looking for it.
You want me to go over it?
Yeah, if you can, real quick.
Okay. So in this problem, of course, it says you throw the ball up, it goes up, and it returns after 3.5 seconds, which means it goes up for half of that. Okay. And it comes down for the other half. When it comes down, then it also comes down at a time of 3.5 or divided by 2 seconds. So the speed for anything that's falling, with initial speed being